All right, this video is going to serve as kind of a review of all of Chapter 2 and the topics of density curves and z-statistic and kind of close this up. So I wanted to do one more example of kind of a regular z-statistic type question, but I also, in the interest of time, want to kind of go through this rather quickly. So if you need more examples or you want it kind of a slowed down version, I would urge you to go back and look at past videos on z-statistic. So for this, the average score in a standardized exam is 56 with a standard deviation of 10. Okay, so I'm also, in the interest of time, I'm going to kind of put all of my pictures on this one normal curve that I put in. So remember, your work, you draw the curve and say it's a normal distribution with a mean of 56 and a standard deviation of 10. Okay, on the AP exam, as well as any exams for my class, this will serve as your work. You've got to draw the curve. You've got to say it's a normal distribution. Now, right now, that seems like, what else would it be? But believe me, as we go along, you'll learn more distributions. So this serves as your work to say, I've identified what I'm using. So, what proportion of test takers were below 50? All right, I'm going to kind of color coordinate this. So below 50, I'm going to, let's actually change it. Let's do it in blue. Okay, I'm going to change that to blue. So for number 1, we'd say, well, the mean was 56, so 50 is going to be somewhere down here. And we'd shade. So this would be your work for number 1. Okay, for number 2, and I'll show the calculator work for all of these in just a moment. For number 2, it says what proportion are above 70. So let me put this work in green. So you'd say 70 is somewhere up here. And since it's above, we shade up here. So again, the curve and the green shading would be your work for number 2. And number 3, let's put in yellow. Okay, so we have 52. And we have 62. So your work for number 3 would be to shade the area between them, like that. All right, let me drag in the calculator work. All right, so let me try and move this calculator stuff here that's off of the side into a spot where we can read it. Okay, like this. So I did a normal CDF. Remember, we talked about why you'd use a CDF instead of a PDF. The PDF we really won't use in AP statistics at all, so don't really worry about that. So normal CDF. For that first question, number 1, remember we were doing the 50. Okay, so I did from this large negative number up to 50, mean and standard deviation. Okay, there's the proportion. 70 and above, mean and standard deviation, there's the proportion, and between 52 and 62. So it's always lower bound, upper bound, mean, standard deviation. All right, let's look at, on the next slide, at the last 3 questions of this example. So, what scores align with Q1 and Q3? So again, I'm just, your work would start with saying it's normal, 56 and 10. Let me do the work for number 4. Let me do that work in red. Okay, so you would say, Q1 and Q3. And this would be the case where you're looking for a score, so you'd use the inverse normal function. So we always write the proportion below. So Q1 has 25% below. Q3, of course, has 75% below. So that would be your work, and then you'd use the calculator, and I'll show that in a moment. All right? Now, Alex said he scored in the 70th percentile. What's his score? Let me put this work in blue. So you could either write an X or you could write Alex's score or something like that, but you're going to put this line and say, well, Alex is scoring such that a proportion of 0.7 is below him. And finally, Jen says she scored in the top 15%. So again, you put something, you say, well, let me put this in green. Jen is here. And if there's 15% above, that means 85% or 0.85 is below. So again, I'm putting this all on the same curve just in the interest of time. Normally you do all of these separately, but this would be your work for each one of these questions. Okay, let me drag in the calculator work again to show you kind of the way you would type this in. And again, if you've forgotten this, I would urge you to go back and watch an older video. So for the first question, I actually had to do two inverse norms. I had to do one that I said, well, I want an area of 0.25 below, and the other I had to do 0.75. So this is Q1, and this is Q3. So from 49.26 to 62.74. Okay. For the question about Alex being in the 70th percentile, so 70% or 0.7 below, there's Alex's score. And finally, for Jen, 15% above, so 85 below, there's Jen's score. All right, I just wanted to close this up with a couple of final things. First of all, how do you know something is symmetric? Well, certainly you could graph it, right? You can always do a graphical check to see if something is symmetric. However, we have a way to do it pretty nicely with just using statistics. We're checking if the mean and median are the same or approximately the same, okay? Now, how do you prove something is normal? I'm going to write one thing and then just talk about it. It's these percentages that make a curve normal. Lying within 1 standard deviation of the mean, 2 standard deviations of the mean, and 3 standard deviations of the mean. It's very difficult to prove something is normal. And I kind of bring this up because a lot of times we see something that kind of has that mound or that bell shape, and it's tempting to say, well, it's a normal distribution. Unless you have verified that the data has 68% within 1 deviation of average, 95 within 2, 99, you can't make the leap that something is normal. All you can say is it's mound-shaped, it's symmetric. So proving something is normal is a lot of work. The AP exam will not ask you to do that, okay? And neither will I. So what does the Z statistic represent? Well, first, maybe we should just write down the Z formula one more time. Z is equal to score minus the, for us, we've been kind of doing a sample mean and then a sample deviation. Remember, we talked about the fact you could also do this with a mu, a Greek letter mu, and that means the population mean, and therefore sigma would be the population deviation. What the Z statistic really represents is the number of standard deviations. I'm going to do this away from the mean something is. Okay, so it standardizes things to be in terms of deviations rather than just in terms of a score or a weight or something like that. It's how many deviations away from the mean something is. Okay, the mean of a distribution is 13, and one piece of data that's equal to 11.1 has a z-score of negative 1.21. What is the distribution's deviation? So in this case, it's kind of a backwards thing. We're given basically a score, a mean, and we don't know the deviation, but we do know z. So we could set this up to say that, you know, the z statistic negative 1.21 is equal to 11.1 minus 13 divided by whatever the deviation is. I'm going to use the Greek letter sigma just so we can kind of show that these formulas, they do represent slightly different things. You know, Sx is a sample deviation. This is like a population deviation, but they're kind of interchangeable, at least for what we're doing right now. So we end up with negative 1.21 equals negative 1.9 over this, and in which case we could, you know, through some algebra, through some manipulation here, we can say that the deviation is equal to negative 1.9 divided by negative 1.21. Okay, and you could calculate that. Let me clean a 9 up. and figure out what that is. All right, what percentage of observations lie within one deviation? Well, we already said that's 68%. 2 is 95, and 1.5 deviations. So this, I want you to think about the curve. Okay, so if we're at 1.5 deviations below and above, think about how you would figure out what percent is within there. I think the easiest way would be to use the calculator and do an inverse norm, and let me pop that calculation in. Okay, so here's what I've done. I wanted to know the percent below, or the proportion below negative 1.5. So from negative 1.5 down, and I left a mean of 0 and standard deviation of 1. Here's why I did that. Think about the z-statistic calculation. So negative 1.5 minus 0 divided by 1 gives a z of negative 1.5. So there is your proportion below this spot. Then I did it again for the positive 1.5. And again, I hope you would think that there's some symmetry here, that if 0.0068 is below, that means that 0.0668 is above here. And you'll see that that's true. I left it as a mean of 0 and standard deviation of 1. And again, doing that puts you in terms of just the z-statistic rather than a specific problem. Okay? And then I found the difference. I said, okay, 0.9332 minus 0.0068, and that gave me the proportion between. So 0.8664, 86.64%. Okay? Finally, what is it that makes a curve normal? Well, it's those same old percentages, 68, 95, 99.7, sometimes called the empirical rule. Finally, just talking about density curves. There are two things your book talked about that always will be true of density curves. The first is that they will have an area of 1. All density curves will have an area of 1. And the second thing is that all parts of the curve will be greater than or equal to 0. There won't be any negative things because there's no negative percentages. Okay? Now beyond that, you could talk about things that a density curve represents a proportion of a group that belongs in a certain spot or has certain characteristics. But these are the two things that will always be true of density curves.